And our first speaker here in this session will be Mr. Lorenz Diener from the MTD company, who will talk about multi and hyperspectral SWIR LED light with, we will see, an outstanding performance. So, Mr. Diener, please come in front. The stage is yours.
Mit dem vorwärts, rückwärts? Okay.
Okay.
Thank you for the kind introduction. Welcome to the MTD presentation about the hyperspectral, about the multi and hyperspectral shortwave infrared LED line light. At first, some notes to MTD. MTD designs and produces line lights for surface inspection and optical sourcing since more than 20 years. We deliver lights with spectra in the range of 365 up to 1,650 nanometers, in length up to 6 meters in one piece, and in combination with our seamless connecting flange, we can produce lights up to 10 meters. MTD provides oblique side and far field illuminations as well as multispectral lights with wavelengths with color sensitive triggering. Last not least, we developed in the last year a new multi and hyperspectral shortwave infrared line light, which is the main topic of this presentation. The hyperspectral spectrum is in the range between 1,000 and 1,700 nanometer. We produce the light in length segments of 300 millimeters. So you can order 300, 600, 900 millimeter, and so on. The standard working distance is 300 millimeter. In 300 millimeter, this light is focused. And in the focus, the intensity is comparable to powerful halogens. The main advantages of this hyperspectral LED lights are it's an energy-saving solution with long useful lifetime of LEDs. Another important thing is that you don't have significant heat radiation in the front beam, which is often a problem of halogens. There is some heat consumption, but this you can cool with fans or with liquid cooling. The light is based on a chip-on-board LED line, which is alternately assembled with up to 14 different wavelengths. We use shortwave infrared LEDs of the latest generation, and each wavelength is separately adaptable. We have currently in stock 2 assemblies, one named shortwave infrared 6, starting from the 1,040 nanometer up to 1,650 nanometer. Another one, the shortwave infrared 9, starting from 1,060 up to 1,550 nanometer. Here you can see the homogeneity of this spectrum, of the shortwave infrared 6 spectrum. And this is realized via our multispectral software, which allows to adapt each wavelength in intensity. And you can store in the light itself up to 16 different wavelengths spectrum combination. we deliver for the slide 2 cooling versions. One fan-cooled system and also a liquid-cooled version. The liquid-cooled is an interesting solution for big industrial application. The fan is often used for lab arrangements. Temperature control is very important because without a stable temperature, you will get always a shift in the wavelengths, in the peak wave lengths. So your spectrum would not be stable. But with good temperature stabilization, on the other hand, you get a really fine stabilized spectrum. A new feature is that now we have the temperature control directly in the light. You can change the set points wireless via some kind of web server. And this temperature controller regulate the fan speed for the fan-cooled version, or regulate via a valve, via a flow valve, the liquid flow in the liquid cooling plate. Depending on the surrounding temperature, the settling time is about 10 to 15 minutes. And afterwards, we have a temperature stability of plus minus 0.5 Kelvin. And finally, this is the basic for a stable spectrum. Another features are red pilot LEDs for focusing assistant. With the pilot LEDs, you can switch on and off. And there's a new feature, the automatic switch off when operation temperature is reached. So you switch on the light, the red LEDs are automatically on, the light warm up until operation temperature is reached, and then the red LEDs will switch automatically off. And in addition, you will get in contact that operation is now right. Compared to halogens, we have with 50% of electrical power the same intensities in the spectrum compared to halogens. So with, for example, for a 300 millimeter light with 120 watt LED power, we can replace 240 watt halogen. Now to some applications. For analytics, the light can be used as a tunable spectral source. You remember that we can store up to 16 wavelengths combination in the light itself. A wavelength combination can be also only one, the singular wavelengths, and so we can switch between the different wavelengths, what is interesting for analytic investigations. For use with dual band cameras, a dual wavelength illumination can be generated. For example, we can combine only via software the 1060 with the water-sensitive 1450 nanometer. And in combination with dual band cameras, you will get 2 image channels. In this example, you see in each image channels some shadowing. This is coming from the sample. But in the different image, you see really clear with a fine contrast the water. 4 separate trigger lines are available for multi-flash arrangements. Each trigger flashes a specific wavelength bands, wavelengths, which you can configure before via software. And the switching frequencies can be up to 100 kilohertz. This allows, for example, some simple kind of sorting in combination with high-speed monochromatic cameras. For each trigger, for each wavelength selective trigger, you will get a wavelength-sensitive image channel. And with the right classification, we can distinguish between stones, potatoes, carrot, and we see also a rotten spot in the carrot. For hyperspectral applications, the MTD light can be used as a powerful broadband line light. You have seen the shortwave infrared spectrum 6. And what I want to show here is some really news. Because compared to 1 year ago, we have now 30% more intensity in the focus. So the LED technology also in this wavelength bands get more powerful. Sometimes it makes sense to use a little bit smaller spectrum because you don't need all wavelengths. For this applications, we have the shortwave infrared 6, starting from 1060 up to 1550 nanometer. And you see it's much more intensity in this only a little bit smaller range. Some applications we have done a comparison of characterization of meat, and it was a comparison of halogens with our LED technology. And you see, you get the same contrast between the fat content and the meat content, so it's comparable. But comparable with only 50% energy. Another example is the hyperspectral characterization of coatings, independent of color. Here you see an example where, for example, the base coat and the clear coat you cannot distinguish in the visible, but it's quite easy to detect in the, with hyperspectral technology in the shortwave infrared. And here the LED in combination with the hyperspectral camera is mounted at a robotic system so that you can investigate also curved surfaces. Summarizing, we remember that there are some new features, in particular the integrated temperature controlling, which is really helpful for temperature, and finally spectrum stabilization. In addition, we have seen that the powerness of the light is 30% higher compared to 1 year ago. The light itself can be used as a tunable spectral source for analytic investigations. The spectrum is adaptable so that you can use it also for multispectral application. For example, you can generate a dual band spectrum for use in combination with dual band cameras. 4 separate wavelength triggers enable, in combination with monochromatic high-speed cameras, some simple kind of sorting, some multi-flash arrangements. And finally, the main and intention of the slides is to provide a powerful homogeneous broadband spectrum which is so stable that it can be used in combination with hyperspectral cameras, where you have finally the best resolution. Thank you for your attention. Welcome to our live demonstration at our booth 10D42. Are there any further questions?
Okay, thank you very much. Okay, ladies and gentlemen, what you saw was LED illumination in the SWIR wavelength range, homogeneous, energy saving. Are there questions? Yes? Wait a moment. Please.
So you said you got a 30% increase in intensity with a combination of improvements in LEDs. Where did the rest come from? Is it with your parabolic reflector or is it with your process?
So it's a combination of more powerful LED chips and also the optical systems, the reflector system. So yes, it's a combination. Yeah. Because you are right, the LEDs, there you don't see the increase of 30%, it's perhaps 10%, something like this other. But we optimized also our optical system so that, therefore I said, in the focus you have now 30% more energy.
Okay, thank you. Are there any further questions? And if this is not the case, remember hall 10D42? 42.
10D42.
D42.
At MTD.
At MTD. So thank you, Mr. Diener.
Thank you.